The Sun, the star at the center of our solar system. We often take its constant supply of energy for granted, without really considering it from a cosmic perspective. Our solar system is located in the Orion Spur, a relatively tranquil arm of the Milky Way galaxy midway from the center. The Sun has been around for 4.5 billion years, roughly a third of how long the universe has existed. Before then, it was a low-density cloud of gas called a solar nebula. It collapsed, forming the Sun, and the leftover material formed the planets and other objects in the solar system. It's easy to forget that 99.8% of the mass of the entire solar system is in the Sun. The vast majority of this is hydrogen being fused into helium. This process releases energy, pushing the Sun apart, while gravity fights to keep it together. Photons, the fundamental particles of light, originate at the core and must randomly find their way to the surface by bouncing off countless particles. It can take these photons up to 100,000 years to reach the surface of the Sun, but then just 8 minutes to reach the Earth if they're headed that direction. Spacecraft in the last half-century have allowed us to observe the Sun like never before. The SOHO spacecraft, situated between the Earth and the Sun, has discovered over 3,000 comets. The ACE spacecraft studies particles the Sun shoots into space, known as the solar wind. We've learned that the Sun is not stagnant. It's a churning ball of super hot matter in the plasma state. This footage of a solar flare was captured by NASA in 2012. Every second represents 6 minutes. Solar flares like these are caused by the magnetic field lines that wrap around the Sun, like the longitudinal lines on the Earth. Because different parts of the Sun rotate at different speeds, these lines occasionally become tangled. The loop you see here is matter that sticks to the tangled magnetic field line. Only with the Earth shown next to it can we appreciate the magnitude of this event. In about 5 billion years, gravity will win the fight with fusion, and the Sun will begin to die. It will first expand into a red giant, enveloping the orbits of some of its closest planets, including the Earth. Upon death, it will shoot its insides out into space, leaving behind a small, dense core known as a white dwarf. It will be at the center of a planetary nebula, which, like a solar nebula, is a low-density cloud of gas, about a light year across. In a way, the Sun will return to its origins. For now, the Sun will continue to support life on Earth, even from a distance of 93 million miles, designated as 1 astronomical unit. Although the Sun is literally a ticking time bomb, it is the slowest one ever created, giving humanity plenty of time to find a new home before the Sun makes the Earth inhospitable.